Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Makfira Malinda Kusnadi from Group 3. The material that I will present is Babylonian mathematics. Okay, first I will discuss about the history of Babylonian mathematics. Babylonian is a tribe that lives in the Mesopotamian region, located between two major rivers, the Euphrates and the Tigris. Mesopotamia is now known as the state of Iraq. Mesopotamia includes Sumeria, Akkadian, and Assyria. This area is very important because it became one of the earliest places where humans lived together in one civilization. History says that the Babylonians were the first to write from left to right and made many written documents. Babylonian mathematics refers to all of the mathematics developed by the Mesopotamian nation, which is now Iraq, from the beginning of Sumeria to the beginning of the Hellenistic civilization. Its name Babylonian mathematics because of the primary role of the Babylonian region as a place of study. More than 400 clay tablets have been found to provide the Babylonian history with excavation dating back to the 1850s. The plates were written in cuneiform writing. The plates are inscribed when the clay is still wet and then burned in a stove or dried in the hot sun, some of which are even homemade works. Next is Babylonian inventor and discoverer. The Babylonian system of mathematics was sexagesimal or number-based 60. This great advance in mathematics occurred for two reasons. First, the number 60 has multiple divisors 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, which makes calculation easier. In addition, the Babylonians had a real number system where the digits written to the left had a higher value, such as the base 10 number. Another achievement in mathematics is the discovery of the determination of the square root value. Even the Babylonian scientists demonstrate the Pythagorean theory long before Pythagoras himself came up with his theory, and this was proved by Dennis Ramsay, who translated an ancient record dating from 1900 BC. The explanation is as follows. 4 is length and 5 is the length of the diagonals. Then how wide is it? They assume that if the two numbers are multiplied by the number itself, the middle value will be found. If 4 times 4 equals 16 and 5 times 5 equals 25, then the difference between 16 and 25 is 9. From what number can we get the number 9? The number must be able to produce 9 if the number is multiplied by the number itself, and 9 is obtained from 3 times 3. So it follows that 3 is the width because all the numbers are multiplied by the number itself. The 4 blackboards found were Yale YBC 7289, Plimpton 322, Susa boards, and Tel Debai boards. Here, the discoveries relate to Babylonian mathematics. First is field of geometry, the second is field of algebra, and the third is sexagesimal number or base 60 number. You can see the following features of Babylonian mathematics. The first picture is the king of Sargon, the second picture is king of Hammurabi, the third is Diopantus. Actually, there are still some figures, but I can find their photos, including Babylonian scientists, one of which is Dennis Ramsay. Then there are Otto Neugebauer and F. Denin, and the last one is Rawlinson. The next material is Babylonian number system. The Babylonian number writing system was known as cuneiform, from the word kuneis, which means slice or part, and the word forma, which means form. Babylonian writing and numbers are often referred to as cuneiform writing because they are shaped like nails. The Babylonians wrote cuneiform letters using a stick that was in the shape of an elongated triangle or triangular prism. By pressing it on a wet clay plate so that it produced a tapered triangular basin resembling a nail image. Unlike the Egyptians, Greeks, and Romans, Babylonian numerals used the correct place value system, in which the number written in the left column represents the larger values. The Babylonian civilization is Mesopotamian replaced the Sumerian and Akkadian civilization in the numerical form. The Babylonians inherit from the Sumerians. Babylonians mathematics was written using the sexagesimal number system. The use of sexagesimal numbers can be seen in the use of times units, namely 60 seconds for a minute, 60 minutes for an hour, and in the use of angular units, namely 360 or 60 times 6 degrees for a circular rotation, as well as the use of seconds and minutes on a circular arc that represents degrees fraction. Here's an example of Babylonian numbers. Okay, the last material is Babylonian of quadratic equations. Implicitly, quadratic equations were known in ancient Babylon. This is shown by the discovery of manuscripts or inscriptions stored in the British Museum. Hirob 1990 states that the Babylonian mathematicians in the ancient Babylonian era known and were able to solve quadratic equation problems, although they were still limited. The method used by the Babylonian mathematicians was a method that Hirob 1990 called naive geometry. Here is one of the simplest problems found in the BM 13901 inscription, which has been translated, which is finding the side length of the square. The problem above is to find the side of a square, given that the sum of the area of a square with the area of the sides is 3/4. Hereinafter will explain the definition of the side of a square according to the Babylonian understanding. The solution to the problems above is not fully explained in the inscription. There are only instructions in its completion. Here is a version translate and interpret into symbols from Redford and Grurete 2000, who also quote from Hirob's writings. The following is an interpretation of geometric shapes and modern algebra with symbols of problems and their solutions. And for Pic 2, the geometric interpretation of the problem certainly makes the problem appear simple. The method used also turned out to be similar to that used by Al-Khwarizmi in proving geometrical quadratic equations. Okay, that's all from me and thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.